All right, so we are back. Um, Now we will be going into the kinematics, okay, in 1D. So let me get my pen real quick. I want to first mention um, that we will be looking at free fall acceleration, okay? And we will really need to establish some kind of toolkit of equations to solve these problems in physics, okay? And these are the three um, main things we need to be looking out for. So we need to find some kind of relation with velocity with respect to time, position with respect to time, and velocity with respect to position. Okay, so finding all three of these equations, these major equations, will give us the tools that we need in order to solve other physics problems. Okay, so I'm going to go over to OneNote real quick and start looking at these things. Okay, so our first equation is going to be similar to what we were looking at earlier. Okay, we're going to start with some graph here, okay, where this axis is t, this axis is v, okay. Our starting velocity v naught is here, okay. Oh, there it goes. I'm sorry about that. That's why it looked funny. Okay. All right. Here we go. So here's our V naught, okay? And there's our T, okay, our T axis. And we're looking at some time T here, for example, okay? Remember that our slope was acceleration when we're looking at our V versus T graphs, okay? Our slope was A. And we want to look at this kind of like how we normally look at graphs, okay? So when we're looking at something like this, okay, where our slope is m, okay, we usually can describe this line with an equation, right, in algebra. And we can describe that as our y-axis equals, or our y values equal our slope times x plus our y-intercept, which we denote as b typically, okay? So we want to do this sort of thing. We want to do this sort of thing now with our kinematics in one dimension, okay? So our y is now going to be v, okay? Our slope, m, is now going to be a. Our x, okay, on our x-axis is now t. And our y-intercept, b, is now going to be our v naught here. Okay, so here we have just derived our first kinematic equation. Okay, so this is going to be number 1. Okay, all right. So I want to give you guys an example real quick. Okay, so say we have a car traveling with initial velocity of 2 meters per second, okay, and an acceleration of 6.0 meters per second squared. Okay, so after t equals 2 seconds, what is going to be our velocity? Okay, so what is our final velocity of this car? Now we can use this equation that we just derived to figure this out. Okay, so velocity, our final velocity, okay, equals acceleration times time plus our initial velocity. Okay, we can also write this as v naught plus at this might be a little bit more common to see. Okay, but it really doesn't matter. Okay, so when we plug in our values, we have our V naught, which is positive 2.0 meters per second, plus our acceleration here, which is 6.0 meters per second squared, times our time, which is 2 seconds. Okay, so we can solve this equation pretty easily. Okay, we still have our 2 meters per second. 6 times 2 is 12. Okay, and so our final velocity is positive 14.0 meters per second. Okay, and so that is how we would use that equation. Okay, all right. Moving on to our next equation that we want to find. Okay, so if we are given initial and final velocities, and we want to know the displacement. And remember, displacement is going to be our delta x. Okay, so we start with knowing that our average velocity, or V average, is V naught plus V divided by 2. Okay, now that is known because when we're taking averages, an average, remember, is going to be the addition of all the numbers. So if I'm looking at one score, say I'm doing, an average of a class, I have some percentage plus another percentage plus another percentage. And say I'm just looking at those 3 students, okay? Divide by 3, that's how I find an average. Okay, so I'm doing the exact same thing here, but now with velocity. Okay, my velocity average. Okay, and we also know that, let's see, that V, when we're looking at our plots, equals some delta x over t. Okay, so our delta x, remember, is x minus x naught, because this is when we were looking at our slope of our, let's see here, our x versus t. Remember when we were looking at our slope had to do with our velocity in this case. So that's what we're looking at here. Okay. Change in position over time. Okay. So if we equate them to each other like I just did, okay, we can find our displacement, or our delta x. Okay. So using some algebra, we can put our t on the other side, and we can get delta x equals let's see. Is that what I'm looking for? Almost. So let me first solve for our delta x. Okay, v naught plus v over 2. And we had to multiply our t over, so multiply by t. Now we can also put in our other form here, this guy here. And we can plug this in so we can get it in terms of acceleration and time as well. Okay, so I am going to say v naught over 2 times t, okay, plus our v, which was up here, that is going to be a times t plus v naught. So I'm going to say v naught plus a times t all of that over 2 times t. Okay. So again, I plugged in my v here as v naught plus a times t, like we had above. Okay. So that's all I've done so far. Now, I can add all of these things together, multiply in and everything. Now I have v naught t over 2 plus v naught t over 2. So that would just give me v naught t. Okay, a half plus a half is 1. Okay. Then my last term is going to be 1/2 a t squared. Okay? So this is my second equation. My second kinematic equation. Okay? All right, so my third one, third and final, I am going to start with my first equation. Okay? I'm going to start with my v equals v naught plus at. I'm going to solve for t. That is my next step. So using a bit of algebra, we're going to say v minus v naught, okay, equals a times t. But I want to divide that out, so I'm going to divide that over here. So now I have t solved for. And now I want to take that t and plug it in to my second equation that I just solved for. Okay, so this is my second equation. So I want to plug it into there. Okay, so I'll do that right here. So delta x equals v naught times t, which is v minus v naught over a. That's not right. Wait a minute. Is that right? I don't know. Sorry, give me 1 second, guys. Okay, let me keep going. V naught times v minus v naught over a plus 1/2 a times v minus v naught over a squared. So it's going to take a little bit of algebra. Okay. I'm going to leave this in this form for a second here and figure this guy out over here. So I've got, I have a 1 over 2. A divided by a squared is going to be an a on the bottom. This guy squared is going to give me, let's see, v minus v naught times v minus v naught. We got v squared minus v naught minus v naught. Okay, this will work out. Plus v naught squared. Okay. I know this is kind of tedious and I'm showing you all the little algebra stuff, but sometimes it helps to work it all out. Okay, so then we have v naught minus v naught squared over a. Okay, so let's see here. This is going to simplify down to v squared for 2a minus, we've got 2 of these, so we have 2v naught for 2a, cross those out, plus v naught squared over 2a, v naught over a minus v naught squared over a. Well, I don't know why it's moving like that. Let's see. That's weird. Okay, that's new. So let's see if I can somehow continue this then. Oops, stop that. Let's see. So we have this guy and this guy, they cancel. Okay. And then oh, okay. So this is a positive 1/2. This is a -1. So we are going to get, let me see if I can get this to work at all. Okay, there we go. So from all of this mess, I'm going to end up with this. Oops, this is actually a negative here. Negative. Okay. And if you're kind of getting bored with all of this, feel free to skip it. I was kind of getting lost in the algebra there for a second, so it happens to the best of us. All right. So, okay, now we can solve for the equation that we're looking for. So we have v squared minus v naught squared. All of that is over 2a equals delta x. Okay, we want to move this guy over. So we end up with v squared minus v naught squared equals 2a delta x. Okay, we can also write this as v squared equals, whoops, I didn't mean to put the 2 there. Okay, v squared equals v naught squared plus 2a delta x. Okay, and that is our third and final kinematic equation that we were looking for. Okay, so through all of that mess, okay, we found this. And so right here, we can see them all together. Okay, so these are our three equations, and we have our velocity as a function of time. So that's v of t. This one, we have our displacement as a function of time. And this one, we have our velocity as a function of x, or displacement. Okay? So I'm gonna move on to problem solving and go through a few examples. So I'm going to take a break, have you guys take a break, and then come back to it, okay?